All right, good afternoon, 7.5, complex numbers as vectors. So we're gonna learn how to do complex numbers as vectors. So what they do to start with, they're gonna teach you how to add vectors. That's the first step. What's a vector? A vector is a distance and direction. It goes in one direction, okay? It has a distance in that direction. So they're gonna give you something that looks like this, 5 kind of little arrows. That's gonna determine your vectors. It's gonna tell you your vectors, and little arrows, 3, 1, I believe. Let me double check my answer here. All right. So I'm sorry, I got the negatives. All right, so once we have our vectors, now, what does that vector look like? So if I were to graph this vector, the first vector would be 1, 2, 3, 4, 5, up 2. So it's gonna go whoop to there, right? Okay, and it's going to have a little arrow like that. Okay, and then from there, you're going to add the -3. So back 3, 1, 2, 3, and up 1. So you go back to 3, up 1. So close enough. That's what you're graphing. What you're looking for is what those two vectors added up to be. Now, another way to word this is your A, this is your B. So if I were to write this as a complex number, it would be 5 plus 2i, and this would be -3 plus 1i. Everybody follow that? If I were to combine these two, how would I do that? Here we go. 5 minus 3 is going to give me 2. 2 plus 3 is plus 3i. And that is what I have there. And that's what I have there. So, what would the combined vector be? 2, 3 with little arrows. So your complex number is basically equivalent to the vector added together. All right, any questions? All right, good. So now let's do a subtraction one. -3, 4, and we're going to subtract. We're going to subtract instead of add. We're going to subtract our next vector of 4, -1. All right, so what would it do? -3 minus a -4 is going to give me a -7. And 4 minus a -1 is going to give me a 5. Questions? So if I were to graph that, I would do the same thing as I would do, is just sketch it out and move it. All right? Any questions there? Now, what happens if you multiply? So that's subtraction and addition. Now let's multiply. So if I want to multiply a vector, and what would that be? Essentially, it's just going to take the vector and make it a little longer. So 3, 1, 2. Make sure I do that correctly. -2, and then we're doing 2 problems here. 1/2 in the same problem. 5, 2. All right. So what would this look like? Well, how would I make this 3 times longer? Well, I'm going to make the 1 3 times longer, and the 2 3 times longer. And there's your answer. So how would I graph that? So as opposed to it being 1 over and 2 down, it's going to be 4, 5, 6, 1, 2, 3, 4, 5, 6, and 3 over. Okay, so that would be if it's 3 times longer. So what about 1/2? Well, what would it be? 5 over 1/2, 5 over 2, and 1. Okay. So in this case, they made it negative. So if I was making it negative, it would be negative and negative. Okay. So now what does it look like? So as opposed to my graph looking like this, here, it's going to do what? It's going to go here. Okay? So basically that's what you're talking about. So all we're doing in this section is dealing with multiplication, subtraction, division, there it is, or addition. And you're just rewriting the equation. Now, the only other key thing that you need to remember is this. A unit vector means it's how far is it going? 1 unit, good. So it's going 1 unit. If it's a unit vector, it's going 1 unit. Now, if I have a horizontal unit vector, if it's going horizontally, what would that unit vector look like? What would the quick way to write that? 1, 0. Good, because it's horizontally. This is the 1, this is 0. It's not going up and down, it's only going this way, left and right. What is a vertical unit vector? Well, it's going vertically, it's not going horizontally, so 0 and 1. Okay, so it's going 1 up or down. These are represented by, this is represented by I, lowercase I, and this is represented by lowercase j. All right? Any questions, let me know. There's 7.5.